Okay, let's get started. Today's webinar, entitled Shorten Mold Design Lead Times with TopSolid'Split. In this webinar, I'm going to introduce you to a few of the tools available within TopSolid'Split that will hopefully show you how to shorten those lead times when it comes to creating your core cavity inserts and action inserts within TopSolid. Without further ado, let's go ahead and begin. So here I'm in TopSolid 7. For those of you that are new to the interface, this is how the software launches. It goes directly to this start page. The start page shows you little icons of what you've been working on recently. What's interesting about them is they're live icons. And what I mean by that, for example, I can middle click on one and I can rotate, pan, and zoom to see if that's the part I want to work on. If it's not, click off it and move on. If it is, double click and get going. If we look on the right side of the screen here I have a project prepared for today's webinar. We're going to go over a couple of different things. We're going to go over a basic split sample. Then we're going to do a split sample in a different way. I'm going to show you the split already done, but then we're going to show you what happens when your customer sends you a design change, how you integrate those design changes. Then we're going to do another split sample where we talk about creating a custom side action insert. We're also going to go over some samples of detecting problems. For example, you can't split the part, maybe the parting edge is wrong. How do you know that? How does TopSolid tell you that? And then finally, I'm going to show you how to do a pretty wicked part modification to invert draft on a part sent to you by your client. So without wasting any more time, let's start with this first sample. This first sample, I'm going to start from scratch. Okay, and what do I mean by that? This file called connector is a Parasolid file. I'm going to go ahead, right mouse button click on it, and convert that document. When I do that, TopSolid's going to load that into a design space, and here I can have a look at my part. Now, the first thing I want to do when I look at the part maybe is I want to run a quick little check on it. I want to make sure that the part is valid, and it is indeed valid. The other thing I want to do is I want to see where the part 0 is. Maybe the customer sent it to you with the part 0 defined, maybe they didn't. In this case, we have a pretty decent 0. It's right in the center of the part up there. That's good enough for me. So from here, what we're going to do is we're going to send this part into a split parts document. There's two ways to do that. I can right click on the tab up here and choose split blocks. I could go to the project tree here, do the same thing, split blocks. What that does is that sends that part into the split box document. Now, the next thing that happens is pretty awesome and pretty important. The software here is asking for the shrink right away. It's one of the most important parts in creating a core and cavity is to make sure you apply the shrink. Now, as a general rule of thumb, I'll tell all users that if your customer hasn't told you yet what the shrink is, but you know it's in a range, enter something. Again, TopSolid is a parametric software, so you can always go back and modify it. Also, I want to point out here that you can do a global shrink or a differential XYZ shrink. We also have two different ways of calculating shrink depending on the types of parts you're working on. We have standard shrinkage and we have expansion. Once that's done, the part is actually ready to split. Now, why do I say that? What TopSolid did in the background is it, of course, applied that shrink, but it also, if I go to my history tree, created a default stock blank for us. Kind of cool. And it's just doing this based on some defaults in the system. So from here, all I need to do is go ahead and generate parting lines. So let's start with our candidate edges command. First thing I got to do is select what direction I want to go. Now, Z positive is our mold opening direction, but as you can see on this part, if I look at it, we have some areas where there's no draft. I have a parting edge suggestion down there and up there. Same thing here. Same thing over here. We got some messes all over the place. So what I can do is go to a precision mode and tell the software, you know what, let's keep all the superior edges. That definitely simplifies things. I'll hit my blue arrow to the right, which leads me to the next command called parting edges. And it's here that I get to select the parting edges that I want to use. So I'm going to go ahead and quickly just do that. When all the parting edges are touching a common face, notice if I just hover over the face, it will select all of them automatically for me. Again, speeding up this selection process. Now, over here, we have something kind of interesting. It looks like we're going to have some kind of pass core going through there. So we got to look at this and say, okay, well, we need to add some parting edges in here. But the software is missing edges. Okay, so I can go here and I can select all the edges I want, but there literally has to be an edge there, right? Oops, I accidentally selected a face. Look at that. So what I have to do is make the edge. And TopSolid understands that sometimes you have to do this on parts. So right here, my little plus sign called Special Inputs, notice I have an imprint command. And I can go imprint by 2 points and create the parting line. And I want to put it on that face. And what that just did is divided that into 2 faces along that edge. And this is a great tool for simple down and dirty things like what we're doing right here. Now watch what happens when we click OK out of this. Notice that the part actually just changed colors. Blue represents the cavity, purple represents the core. Cool, so our parting lines are done. That's how I know as the user that I'm ready to go on to the next step, which is to make shutoff surfaces. So let's go there next. So I'm going to click my shutoff surface command and watch what happens when I do. I'm just going to select my part, and in half a second, if we zoom up and look, you'll see that the software has created every internal shutoff, including the telescoping shutoff, for us automatically. Kind of cool. From there, I want to create my external parting surfaces. Sorry about that. So I have an automatic parting surface command as well. I can just say compute parting surfaces. And there we have all of the external parting surfaces. Think about it. I have imported my part, checked it, it's valid. I've applied the shrink. I've added the parting lines, modified the part where I needed to for my parting lines, added all the parting surfaces, and I did this in a few seconds in all reality. What I'm doing now is running a check on the parting shells. This is going to be what the cavity is going to look like. This is going to be what the core is going to look like. And if you look, there's this orange profile along the outside of both of them. That orange profile tells you as the user where the surfaces are currently open. For example, if we had an orange profile here, that might tell us that we're missing a surface or missing a parting line or something. Okay, so that's one way the software communicates with you. Next, I'm going to ask it to create the blocks. Like that, there is your core shape and cavity shape. And if I hide one of these, you can see the resulting core. Kind of cool. Now, let's take this a step further. I'm going to go back in time, and here I'm going to talk about history a little bit. So we've done a lot of steps to get here, but notice there's only 4 steps in our history tree, or 3 steps, pardon me. It's because we have what we call stages. Stages are a way to organize your work and help you ensure that you do things at the right moment in time. So I'm going to roll back to my parting stage, which is where all my parting surfaces are and whatnot, and I'm going to go add additional parting lines and another parting surface because I need to make a side action for this object here. So how are we going to do that? I'm going to go straight to parting line. We'll zoom up here. I'm going to select that edge. I'm going to show you another way that you can work here. I can just drag that ball along the edges that I want to use. That's kind of cool. Now, in order to finish this, I have to attach it up here. So again, I'm going to do that imprint. And this is going to get pretty interesting actually, because I want to imprint from there straight up this way, but I don't have a point to select. Well, never fear. Always pay attention to the dialog boxes in TopSolid. They almost always have this orange little plus sign, and check it out. I have different snap types available here. So I can go right to here and say, you know what, I want to project a point. Which point? That same point relative to a curve. What curve? That curve. If you want to specify a projection direction, you can. Otherwise, it will be a perpendicular projection. But once that's done, we have our point and then our face to consider. And now we have that parting line. Let's go here and let's take another look. I'm going to do again, imprint, this point, again a projected point from here relative to that edge. Okay, I'm imprinting that face. Okay, and now I'm going to green check again. Now notice the parting shells changed again because now we have a whole nother set of surfaces. It's kind of cool actually. Now what are we going to do with this? I'm going to just go add the missing surfaces. All I'm going to do is take from that edge to that edge, let it extrude out, and we have all the information we need now. watch, if I update my parting shells, notice now the cavity still looks like the cavity. The core, however, has changed, and we now have a set of insert surfaces. If I update, it's going to create the new blocks, and like that, we've added the roughed in insert for the side action. Kind of cool. If we go back to this, can move that up and down. You can see how the insert is going to work. It's kind of cool. And off you go. Now, that's it for that sample. Let's move on to the next one. So I'm going to close this stuff. We can come back to it if there's questions on it later. Next, sample 2. In sample 2, I have my customer data. I have this part here. Okay? So this is the part that I split, and I already did this ahead of time just to save some time on the webinar. So here's the split, and here, more importantly, is the final split where we create it as individual blocks that we then use in TopSolid mold. The question here, let me open that assembly up. So here you can see that final split. The question or the point here is, what happens when your customer sends you a new database? Now, I joke around with people all the time about this. I say your customers are always the best customers, and they get their part designs designed correctly the first time. In all reality, part changes are just part of life in a mold designer's world. So how do we integrate those changes? Well, let's have a look. First of all, if you notice, there's padlocks in all my files. Before I make any part change, I check in all my data into the TopSolid PDM vault. This way, I have a revision of it the way it was prior to the change, which is always a good idea. So now I have my cover 1A, I'm going to convert cover 2A, and here's the best part about what I'm going to show you is these design changes don't have to come from TopSolid. They can come from any CAD platform on the planet. Now, if you look at this part, you should see right away what the difference is. But in case you don't, there's a big gaping hole in the side. If I go back to cover 1A, no gaping hole. So how do we tell TopSolid now that that gaping hole exists? Well, we use a tool developed by TopSolid called compare and replace. Now, if I was just quoting the change, all I would need is compare, and that would show me the changes. But because I'm a designer, and you know what, they sent me the database, I just got to push it, I'm going to go straight to replace. When I go to replace, and let me minimize this one for the moment. When I go to replace, the software asks me what document I'm replacing it with. So I'm going to go here and pick it. It's because cover 2A was open. Now, the first thing that the software does in this case is it puts you into a synchronous mode where you can actually see any face up close on each part, so you can help identify yourself where the changes might be. But if you notice, there's a little arrow to the right up here, which means I can click Next. If I do that, the software runs an analysis. It finds all the same faces, and it finds all the different faces. And notice it's mapping the change onto the existing design. Let's hit Next again. From here, the software is saying, is there anything special you need to do? Maybe there was a face that has no reference to match it with. Fine. Hit green check mark. Now here's where the magic happens. Notice I'm still on cover 1A, which is the original file. However, it has the updated faces. And this is the real key element. I'm not actually replacing one file by another file like most people do in other systems, because that would destroy all of the parametric links downstream. What the software did automatically was it applied the changes. It found them and it copied the faces into my existing document, modified the part with them, but all the other faces are still the original faces, still the original edges. This way, everything tied to them in the parametric world will update accordingly. Now, from here, I'm going to hit Save. How do I know what that modified? Well, if I look in my project tree here, notice that my split has this little symbol on it, as well as the final split downstream. So now I have to update them. How do you update? You double click, you open them up. Software is going to go ahead, it's going to regenerate, but it's going to give me a rebuild problem. Now, where do I see the rebuild problem? You see a little red dot up here, or down here in the Windows status bar down here. If I click on the red dot, it takes me right to where the problem is, and it's telling me parting edge definition not sufficient to split the shape, which makes sense if you think about it. So I'm going to go ahead and bring back my history here, and I'm going to roll back to that parting stage. Why? Well, simply put, it's because you can see there's no parting line there. So what I'm going to do, just because I like to keep things in order, I'm going to roll back in time, back to my parting edges, and I'm just going to add that missing parting edge. You'll notice when I do, it resplits, perfect. And if I rebuild, it even adds the surface. That's pretty cool. And if I update my shells, perfect. And there's my shapes. So the first thing I did was I updated everything. Now, there's still more work to be done on this sample. We still need to make a side action, right? Because you can't have that detail in there without clearing it out somehow because you have trapped material. So first thing I always do is get rid of my rebuild errors. Next, I'm going to go back to parting stages, and I'm going to create a sketch. Because what I need is I need parting lines where there are no parting edges. Now, where do I want to create the sketch? I want to draw on this left side, looking that way. When the software creates the stock blank, it also creates a series of planes outside the stock blank. So here I have a stock X negative plane that I can draw on. That's perfect. And the reason I want to draw on that is if I change the block size, this plane will follow suit. And now what I'm going to do is I'm just going to quickly pick some points here. Oh, let's zoom up here. Let's get right there. I'm going to go over to here, come down to there. And now we're going to add a couple of constraints. So here I want to be, let's say tangent between this and this at that point. Tangent between this and this at that point. I'm also going to add a quick dimension, and we're going to talk about what we just did there. I'm going to go here, say this is 30 degrees, 15 per side. Now, I made this tangent to that, right? But here's what's cool. Remember, I'm drawing out here in space, and that is an arc on its inclined plane, but because it's an inclined plane different than this one, it's really some kind of spline. But we're able to add tangency to anything in TopSolid. Okay, now that that's done, I want to use that sketch to imprint. Now, maybe you've noticed, but during all of these demonstrations I've been doing so far, I've been right-clicking a lot. TopSolid's interface is designed to propose to you the tools you're looking for at that moment in time. Okay, now let's say you're not a right-click person. No big deal. You could go up to the Surface tab and go find the imprint icon, or the Surface pull-down menu and go find the imprint icon or imprint function. Okay, doesn't matter how you get there. The point is you got there. Now I want to imprint in that direction. This is the shape I want to modify, and most importantly, that's the face. Perfect. Now it's divided those into a few edges, and here we're going to go ahead and add our missing parting line, and then we're going to add our missing parting surface. We'll go from there to there. Nice. And lastly, let's update our shells. Perfect. It'll update the shapes, now creating a new shape called an action insert. And finally, we're going to update that assembly. And it's going to create that new side action insert for us as well. So in this sample, what was interesting is in a few minutes, I was able to take a design change from my client and push it using automation to find the design change and to push that design change onto the original part. And then I walked through the history of TopSolid, updating and fixing because we had new features that weren't taken into account before. And now we're to our final stage where everything is updated. Now, let's say you went through all that work and then your customer calls you back and says, hey, you know what? I forgot, I don't want that change. Well, what can you do? You have two choices. Because I haven't checked the change in yet, I could literally right-click, undo change. That's going to go back to the previous revision. I could right-click, undo change. That's going to go back to the previous revision. Okay? You can go through this all the way back, which is kind of cool. Now, let's move on to our next sample. From here, we're going to do, and let me show you the completed version. We're going to do this part here. If I go ahead and I look at this in split view, okay, so we have this fancy part, and it's this side action that we're going to talk about how we're going to fix. We're also going to correct a bad draft problem on this part, okay? So let's go ahead and do this one from the beginning as well. First thing I'm doing, I'm importing, the part has been imported, okay? If we look around at this part, the first thing I want to know is how is it drafted? So let's go ahead, go to our analysis tools, and let's run a draft analysis tool. We're going to say that the Y positive direction here is our mold pull direction for the moment. We'll click OK. Now if we look at this, green represents no draft, yellow is draft in the right direction for this side, blue is draft in the other direction on the other side, okay? Now if we look around at this, I see this thing here. Now this you can see is transferring colors all over the place. And yeah, I suppose we could step the parting line through there, but that's a big mess. And our customer said, you know what, you guys can flare that out as much as you want to just put it in line of draw. So let's do that. I'm going to come here. I'm going to create a sketch. I'm just going to copy this edge. Okay, and there's a couple of different ways to do this. I'm using one way, which is I'm going to extrude this. So when I extrude this, I want to extrude this relative to that Y direction as a surface going the other way, right? So I'm going to flip this down the other way. Now, that's good, but that's not going to add draft, and that's what we want. So I'm also going to ask the software to add 10 degrees draft. Pretty neat. Now, we don't have to go crazy with the thickness here. Let's maybe go far enough that we know we're hitting those faces. Perfect. So now we have our 10 degrees draft in line of pull. And I'm just going to use a little magic trick called replace face. I want to replace this face with this one. And you see a preview show up there? Boom, we've modified that, and now that is in line of draw. Kind of cool. Now, the rest of this we're going to do inside the TopSolid'Split document. So here, I'm going to send this into split parts. Notice really quick, it's oriented one way, and then when it comes up to shrinkage, it's orienting another. That's because it's taking the frame from the design document, and it's using that to position into this document. Here we're going to apply our shrink. It's going to shrink the part, and off we go. So let's go ahead and start with our suggested parting lines. Again, relative to Z. Notice there's parting lines everywhere because there's lots of 0 degrees draft and things like that. Again, I want to stick everything to the top side if possible. That cleans it up nicely. And I'm going to go ahead and start creating parting lines. So I'm going to get that one to start with. And then I'm going to turn that mode on. I'm going to select this face because, again, all of those are common. We'll come over here, that face, perfect. And then we're just going to select these along the top. They're nice and easy. Awesome. Now we have this last one, and we're done. But we're not, because the part didn't change colors. We thought we had enough, right? But if we look up here where the thread is, we need to have a shutoff. Now, in this case, I'm just going to say, let's shut it off on top. Perfect. Now everything is divided up, and now we can go create our parting surfaces. So let's again start with shutoffs. Select our part. Those are easy. They're all a bunch of planar shutoffs. Let's now go to our parting surfaces, have it calculate that. That looks good to me. Okay, and let's go create our shells. Shells look good. Let's create our shapes. Shapes look good. Now, again, just to reiterate, let's hide this one. We have our molding detail. We have our shutoffs. Everything is color-coded so that you know what's what. Now we need to create side actions. For what? Well, let's go back to parting stage. For these, because we have trap material, trap material, trap material. Now, what I want to do is I just want to bring these out and then attach them to a common insert. So this is going to be somewhat automated, somewhat manual, just to show you that at the end of the day, where automation doesn't work or isn't perfect, let's say, with TopSolid, you still have best-in-class design tools to get the job done. So here we go. Let's start a new sketch. This is going to be in the Y- plane, so let's go look for our Y- plane. Perfect. And now what I'm going to do is I'm going to copy some edges. Just nice and simple. I want that edge, that edge. By the way, to manipulate my view, I'm using a space mouse. You can also use regular mouse shortcuts to rotate, pan, and zoom. Okay, so now we have all those. I'm going to look straight at them, get out of that command, and I'm going to window select all of those and delete their coincident relationships. Then I'm going to window select them again and do a magic trick. I'm going to align them all. By aligning them all, that means they're all following at the same time, and I can then drag and drop this to make a coincident relationship down there. Just fast sketch modifications. Next, I'm going to take this and I'm going to create an imprint. I want to go this way, and most importantly, I want to modify that shape where this face, this face, this face, you're seeing the previews showing up in orange. Perfect. Done. Let's go back and let's define the parting lines for that. So now here, we're grabbing our parting lines. All right? And again, you could drag all you want. That one's done. I usually do one parting line at a time just to make sure that it's clean. Do the same thing over here. Here I'm using rotative selection. Every software has a way to select through and select multiple things. That one's good. Let's do this one next. Whoops. Don't you hate when you select too much? Go ahead and drag that down. That's a little faster. Perfect. So we have 3 new sets here. Now let's go ahead and make the surfaces. So I'm just going to go to my parting surface command and I'm just going to use simple extrusions. Okay. I want to extrude this like so, this like so. I should also explain why am I not setting an extrusion depth. It's because the software is going and first of all finding the direction automatically, and secondly it's extruding to the nearest stock plane, which it chose automatically because of the extrusion direction to be the Y-. Okay. Now I'm going to switch to planar surfaces. Do that one. We'll do the one back there. Why not? So we're just making simple, common surfaces. Like that, we have everything we need. So as I step through these design changes, I always like to go and test them. That's perfect. Now notice we have the beginning of our side action inserts. We have our saddle shutoffs over here. It's okay. Click OK. Blocks will be updated as well. Not too bad. However, we want to turn these into just one big side action. So no big deal. Let's go ahead and do that. Just saving really quick, and then we're going to go back to parting stage. So now here what we want to do is a couple things. We're going to modify all of these faces, but we're going to modify them also with the use of additional faces that we create manually. So let's begin. To begin with, what I want to do, I'm going to kind of look at this from the side, and I'm going to select all those faces, right-click, and delete from parting surface set. That means the software is not going to look at those faces in the split right now. We're going to add them back, but we're going to add them back once we've created all the modifications we want. I'm also going to go ahead and sew them together because it's going to make it faster to work with. Now notice as I'm sewing, you're seeing that orange profile again. That orange profile is TopSolid's way of showing you where the surfaces are open. Again, if we saw an orange profile where 2 faces came together, it would mean that there's a gap there. Got to go fix it. Good. Now, next, I'm going to build a sketch where, again, on one of those stock planes, this one again is going to be the Y-. Perfect. And now let's maybe look straight at it. And I'm going to come over here. I'm going to come up at some angle, come over, come down at some angle, and we'll come back and close this. Now, I do need to add some dimensions because, I want this to be to some specific size, right? So I'm going to start by adding an angular dimension, and I'm going to right-click and say, you know what? I'd like that to be a centered dimension, meaning symmetric about something. And I want it to be 30 degrees, well, 15 per side. I'm going to say this from my main parting line is going to be 1 5/8. Maybe this point to the center of this is going to be something, or you know what? Nah, I don't like that. Let's go here, delete that. Let's go here to our main 0 so that the guys have to make this can work to a more standard size. I like that better. Let's go there to our 0. That'll be 5 1/4. And now, just for fun and because I can, let's add some fillets up here. And 3/8 is what was in there because that's the last value I used. I'm good with that. So now let's go ahead and extrude this. So now we're going to extrude this as a solid. Some distance this way, maybe 1 1/2. Looks good to me. Perfect. Now I have a solid, I have surfaces. I need this to be a surface model. So I'm going to go ahead and remove some faces. Okay, and I don't want to heal them, so I'm just going to set them to none. I want to remove this back face and the bottom face. Now I'm left with a set of surfaces. And finally, I want to trim this stuff together. So I'm going to go to my Shape tab, and I'm going to go to a command we call reciprocal trimming. It's kind of cool because this one will trim one set of faces to another set of faces. It's kind of cool. Let's do it again. I want to go from this one to here. That looks good. I want to go from this one to here. That looks good. And now if we look at everything, everything looks good on the inside. You could even throw some fillets around this if you really wanted to, but I think you'll do that after. And from here now, I'm going to sew the rest of them together. Now the sewing isn't so important. I just like to do it when it's custom shapes, because this way I know that everything is clean and perfect the way I want it. Now that we have that, I'm going to get out of that command. I'm going to right click, add that in parting surface set. And let's go ahead and update everything. And now notice we have our combined side action insert. We have our big saddle with the little saddles, so that's kind of cool. And we're done. Life is good. Okay, so that completes this sample. So this is showing you A, how we did some modifications, B, how we were able to create more of a custom action insert using both standard TopSolid'Split tools as well as standard TopSolid design tools, and that we were able to work freely and quickly to get to that end result. Now, let's take a look at some other samples. If I go into my detecting problems, I have one called open parting edges. So let's go take a look at this one. So this has some kind of connector file. You can see it's a nice big, some kind of electrical connector. We have parting lines everywhere. We have parting surfaces everywhere. But we have a problem because it's all the same color, right? But whenever there's a problem in TopSolid, TopSolid tries its best to tell you as the user where the problem is. And maybe you see it. You see this little green ball right here? That green ball, if I zoom way up, is showing me where the problem is. I have a microscopic edge that was missed in my parting line detection. In fact, it's so small, it's not showing up in my length measurement down here. That's tiny. So how do we fix it? Right-click on the parting line. Go to Edit. We can just add that edge back. Sorry, I think I misselected. Let's do it again. Edit. There we go. Perfect. When I click OK, you'll see that the parting line returns and the part turns the multiple colors it needs to be. Now, I think at this point you understand we're very, very fast at surfaces. This is just to show you how to find and isolate a parting line problem. Okay? Let's save that where it is in case we want to come back to that. If I, really quick, just to show you the completed project, if I go here and I go to my split view. So here you can see everything has been created. You have the core block with its shutoffs. You have the cavity block with its shutoffs. Everything is done. Now, let's look at another sample of finding and correcting issues. So on this part, again, this is a part that's got a ton of parting lines in it. And you're looking through this model and you're like, okay, clearly I'm missing a parting line somewhere, but I cannot tell where it is. Well, in TopSolid'Split, we have a wonderful new analysis tool called Analyze Parting Edges. You select the starting face, and then what the software is going to do is it allows you to kind of click through, and it's going to start kind of attaching a color to faces that are on the correct side, okay? And the goal is, as you click through here, to find where the color bleeds through to the other side. And here it's showing where the color is bleeding through. And if we look over here, there's a parting line, there's a parting line, but hey, lo and behold, no parting line. So we would have to go here and we'd have to define said parting line. So let's do that. If I go back to my split blocks and I go up to here, I can now go and select that whole loop. And when I do, everything of course will change colors and off we go. Now, just to show you some of the surfacing power again, let's go back to our shutoff surfaces, right? And let's select the part and see what it finds. Now it's thinking because it's got a lot to think about. Now it's found a lot, including one down here that we don't need, so let's go and ignore that one. Perfect. Green check. And you can see it's made almost all of those shutoff surfaces for us. I mean, how wild is that the software can work that well? On these openings, it didn't know which way to go with it. And let me explain why. If I go to manual mode here, and if I select this face, okay, and I go to this mode, this mode, I'll show you what it's doing. It was trying to make a shutoff like that, but it was getting confused whether it should go up, down, left, or right because the surrounding geometries just don't extend because, well, there's nothing to extend in this case. So we don't do the constrained surfaces in automatic mode. You'd have to go and select them. But as you can see, it's not the end of the world. Select a face, right click OK, hit enter on the keyboard, hit OK. You can go through this stuff really fast. So since we're doing it, let's do it. And again, while I'm doing this, let's talk about some of the advantages. So TopSolid has been around for over 35 years. We've been doing mold design solutions for 25 of those years, I believe, maybe a little bit more. We understand the design challenges that mold designers face, and we've worked diligently over the past 25 years to really make a solution for you guys. Here, let's go to planar. Let's choose this outer one. That's done. Cool. And now we should just be able to go ahead and create our shells. Cool. And of course, since the shells are clean, we can go ahead and create our blocks as well. Nice. Now, if we hide the core shape, so there's your cavity with all the shutoffs colored for you so you know which are the critical faces. Everything is done. Very, very nice. All right. Let's look at one more quick sample. We have two more samples that I'm going to show you today. One is how, in making sub-inserts. That's where we're going next. Then we're going to show you how you can follow the natural draft of the feature that you're inserting. And then the final one's going to be a pretty massive part modification that really doesn't take that much work. So let's go ahead and go to the demo side of this. This one's going to open up. I have a dynamic section plane turned on, okay? So everything is pretty much done in here. It's just a little cap design. But what I'm going to show you is this. If I go right click and edit this insert surface, we have a nice little option here. There's draft on this. And because there is, I have this option. Now watch the surface over here when I turn it off. It can be straight or it can follow the draft angle. So I'm choosing to follow the draft angle by 20 millimeters. Okay, that means the length of that extrusion. Now let's go ahead and turn off this section for a moment. Okay, oops, it seems that we need one more quick surface. Let's go there, great. And let's just split this really quick. Now, this is interesting. Notice I have a red curve. The red curve means there's a problem. Let's go back and check. Well, what could that problem be? If I look at the stock blank size that was made, notice how that surface is not extending all the way through the stock. That's what that red edge is telling us. So all I need to do is go add the surface. So let's go ahead, go to extrude. We'll just do this on the fly here. Okay, I'm going to switch to edge extrusion and just grab this. I want this to be a surface. And as far as where I want this to go, I want to limit it to a plane. Which plane? Well, the Z- plane, of course. This way it follows my design intent. Lastly, I need to add this in the parting surface set so that it takes it into consideration. And of course here now, if we go do the split, orange curves everywhere, which is what we want. Let's go make our final shapes. Here we have our internal insert following the draft angle up to an extent or up to a specific point, and then just going straight below that. Perfect. Ready to rock on this one too. So hopefully these split samples, insert samples, they've shown you that TopSolid really does a good job at managing the core and cavity split process, the insert process, the action process, everything. Now, let's take the final look at part modification, because sometimes your clients will send you parts that aren't designed correctly, right? So here's what we're going to look at. So here's my part, okay? And I've done some corrections to this already, but what I'm going to focus on now is in this area here. What I want to do, and let me go hide some of these planes because I don't need to see them. There we go. What I want to do is I want to reverse the draft at this level down so that I can bury this rib on the core side properly, because right now this is drafted as part of the cavity and it's just going to make a goofy shutoff. Okay? Customer said I can do it, but I have to do it. Now, with that type of change, the challenge is you have lots of fillets, lots of things you got to deal with. But what if you didn't have to? Let me show you what I mean. I'm going to go here and start a sketch. And I'm just going to copy this edge here. Okay? Look straight at it for a second. And again, I'm going to remove the coincident relationship there and there. I'm going to extend this out that way. We'll extend this out that way for now. I'm going to add a quick dimension just because I always like to be fully constrained. Sure, why not? Don't really care what the size is. Notice I'm in my dimension tool. I can still resize geometry while I'm in it. That's kind of awesome. We can go there, come down. Sure, I like round numbers. Good enough. Now, what am I going to do with that? I'm going to imprint, first and foremost. So let's go to imprint. I'm going to imprint that curve based on a specified direction along the x-axis. Okay? And I want to imprint on this face, and I'm going to imprint on all the faces going around, in fact. That's perfect. There, and there. Awesome. Okay? Now what I want to do is I'm going to make a draft angle. Okay? But before I do that, I need a reference plane. So let's go to construction, and I'm going to create a plane on point and normal. And why not? We'll choose this right here. That's my point. My normal is going to be the Z plane. Okay? And now I'm not going to use my draft command, because if I wanted to use the draft command, I'd have to strip all of those fillets off. And I don't want to do that. I'm lazy. So instead what I'm going to do is use face modifications. Now face modifications are pretty cool. They are kind of like a direct modeling tool. Okay? So I'm in face modifications. In here I can pull things, I can rotate things, or I can taper things. So I want to reference that plane, 1 degree, and I want to just start selecting the faces to taper. Now, you'll see a preview of it, okay? I have that going the wrong way. Now you see it's adding the 1 degree that way, okay? And now what I just need to do is go around and select the faces that I want to modify. And this is the key element here. Notice I am not selecting any of the surrounding fillets or anything. I'm just selecting the root face modification that I'm after. And as long as we see that preview, it's going to do it. And what do I mean by that? I mean it's going to modify our geometry. And by modify, it's going to move all of those fillets along with this modification. And what's even cooler about this is the fact that it does this on imported geometry or geometry that you have designed in TopSolid. Sometimes a direct modification like this is the way to go. So we see the preview. I'm going to click OK and watch those fillets. They all just moved. I've now inverted the draft, made my shutoff a heck of a lot simpler, and I did it without spending a day stripping fillets off, redesigning everything. I did it in a few minutes. After all, if you can't react quickly, how can you stay competitive in your market? At this point, that completes what I wanted to show everybody today on this webinar regarding TopSolid'Split. For the next few minutes, I'll open it up to any direct questions. So if any of you guys have any questions, feel free to type them into your question bar there now, and I'll do my best to answer them. And then if nobody has any questions, then I'm just going to say thank you for attending today's webinar. The webinar has been recorded and it will be sent to you via link if you want to rewatch it or share it with any other engineers that you know. Oh, we have a couple of questions. Nope, just some comments. Cool. Thank you, Zoran. I hope you enjoyed it. Have a great day, everybody.